In 1977, humanity launched two robotic spacecraft that would eventually become some of the most extraordinary explorers ever created. Their original mission was relatively simple: travel through the outer solar system, study the giant planets, and transmit scientific information back to Earth. Nobody could have predicted that their journeys would continue for decades. The timing of the launches was incredibly important. A rare alignment of the outer planets created an opportunity for spacecraft to use gravity assists to gain speed and change direction. Instead of carrying enough fuel to accelerate continuously, the probes could pass near massive planets and exchange a tiny amount of orbital energy for increased velocity. This technique dramatically expanded what a spacecraft could accomplish. Voyager 1 and Voyager 2 were sent toward the distant worlds of the outer solar system. As they encountered the giant planets, they revealed environments that were far more active and complicated than scientists had imagined. At Jupiter, the spacecraft observed enormous storms, powerful atmospheric activity, and remarkable lightning. The planet's moons proved equally fascinating. Io displayed intense volcanic activity, while Europa showed evidence suggesting that an enormous ocean could exist beneath its icy exterior. The discoveries changed planetary science. The outer solar system was no longer simply a collection of cold objects orbiting far from the Sun. It contained active worlds with geological processes, hidden oceans, volcanic activity, and complex interactions between planets and moons. Voyager continued toward Saturn. There, its cameras captured remarkable details of the planet's famous rings and revealed new information about Saturn's moons. The observations demonstrated that the rings were not simply static bands surrounding the planet. They were dynamic structures influenced by gravity, collisions, and interactions with nearby moons. After completing their planetary encounters, the spacecraft continued outward. The technology behind these missions makes their survival even more remarkable. Voyager was designed in an era when modern smartphones, powerful personal computers, and today's advanced digital electronics did not exist. Its computing capabilities were extremely limited compared with contemporary machines. Yet the spacecraft continued functioning across enormous distances. It survived radiation, extreme temperatures, mechanical stress, and the near-perfect vacuum of interplanetary space. Its signals became weaker as the distance from Earth increased, but enormous antennas on our planet continued receiving them. Every transmission represented an extraordinary achievement. A spacecraft built on Earth was communicating from billions of kilometers away. Eventually, Voyager traveled into a region that no human-made object had explored before. The spacecraft approached the outer boundary of the Sun's influence, where the solar wind begins interacting with the surrounding interstellar environment. Scientists had expected this transition to behave like a relatively clear boundary. But nature proved more complicated. The region around the heliosphere turned out to be a complex interface between material and magnetic fields associated with the Sun and the surrounding interstellar medium. Measurements did not simply switch from one environment to another at a single obvious line. Instead, researchers observed gradual changes and unexpected behavior. The spacecraft detected changes in energetic particles and magnetic conditions as it moved farther outward. Eventually, observations provided strong evidence that Voyager had crossed into interstellar space. Humanity had reached beyond the protective bubble created by our star. That achievement represented something far greater than a distance record. For the first time, instruments built by human beings were directly measuring the environment between stars. The data gave scientists an opportunity to study cosmic rays, magnetic fields, plasma, and particles that cannot easily be examined from Earth. And Voyager continued moving. Its journey demonstrated that exploration does not always require a human traveler. A small machine can carry our questions into places where people cannot yet go, collect evidence, and return that information across unimaginable distances. But its story was only beginning to approach its final chapter. As Voyager continued traveling away from the Sun, its measurements became increasingly valuable. Every observation from the distant frontier offered scientists another opportunity to understand the environment surrounding our solar system. The heliosphere is not a simple wall separating the Sun from the rest of the galaxy. It is a vast region shaped by the solar wind and the interstellar medium. Where these environments meet, particles and magnetic fields interact in complicated ways. Voyager's measurements helped demonstrate that this transition is far more complex than earlier models suggested. The spacecraft detected changes in particle populations and magnetic conditions, allowing researchers to investigate what happens as solar influence gradually gives way to the wider galactic environment. This was an extraordinary scientific achievement because the spacecraft was never designed with modern technology. Its instruments were developed decades ago, yet they continued producing useful measurements from a region unimaginably distant from Earth. The signals arriving at Earth became incredibly faint. Mission teams had to carefully manage the spacecraft's limited power and scientific instruments. As its energy supply gradually declined, engineers faced difficult decisions about which systems could continue operating and which would eventually need to be shut down. Eventually, Voyager will become silent. Its power source will continue weakening, and there will come a time when Earth can no longer receive meaningful scientific data. Communication will end, but the spacecraft itself will continue moving through space. And this is where another remarkable part of the mission begins. Attached to Voyager is the famous Golden Record. The record contains sounds, music, greetings in numerous languages, and images intended to represent life and civilization on Earth. It was never realistically expected to function as a practical communication system. Instead, it was created as a symbolic message carried into the unknown. Its existence reflects something deeply human. Humanity did not send Voyager into deep space only because scientists wanted measurements. We also sent a small representation of ourselves. The record carries the idea that somewhere on a small planet around an ordinary star, intelligent beings became curious about the universe and decided to explore it. The spacecraft itself became a kind of time capsule. Long after its instruments stop functioning, Voyager will continue traveling. It will no longer send information back to Earth, but its physical presence will remain, drifting through interstellar space. It will carry its message long after the civilization that launched it has changed. That is perhaps the most powerful part of the Voyager story. The mission began as an exploration of Jupiter and Saturn, but it became something much larger. The spacecraft helped humanity understand the giant planets and their moons, provided observations from the edge of the heliosphere, and eventually entered the interstellar environment. It also demonstrated the extraordinary durability of carefully designed technology. A machine created almost half a century ago continues to send information across billions of kilometers. Its survival is a reminder that scientific exploration can outlast the era in which the technology was created. But Voyager's greatest legacy may not be a single discovery. It may be the perspective the mission gave us. From Earth, the solar system can appear enormous, yet Voyager showed that even this vast region is only a small neighborhood within a much larger galaxy. Beyond the planets lies an enormous expanse filled with stars, magnetic fields, cosmic particles, and unexplored environments. Voyager crossed that boundary carrying humanity's curiosity with it. Eventually, its signals will fade. The spacecraft will continue onward without us. The Golden Record will remain attached to it, silently carrying evidence of a civilization that once looked toward the stars and wondered what existed beyond its own world. Voyager's journey reminds us that exploration is not always about reaching a destination. Sometimes, it is about sending something forward into the unknown and allowing it to carry our questions farther than we can go ourselves. And long after the final transmission disappears into the silence, Voyager will continue its lonely journey through the galaxy. A small, silent reminder that humanity once looked beyond the edge of its world and dared to explore.